Friends, welcome you all on our today class, and our today topic is registers and counters. Now let's see what are the registers. Flip-flop is a 1-bit memory cell which can be used for storing the digital data. To increase the storage capacity in terms of numbers of bits, we have to use a group of flip-flop. Such a group of flip-flop is known as register. The n-bit register will consist of n number of flip-flop, and it is capable of storing an n-bit word. The binary data in a register can be moved within the register from one flip-flop to another. The registers that allows such data transfers are called shift registers. There are four modes of operation of a shift register: serial input, serial output, SISO, serial input, parallel output, SIPO, parallel input, serial output, PISO, parallel input, parallel output, PIPO. Now the serial input, serial output. Let all the flip-flop be initially in the rest condition. Q3, Q2 equal to Q1 equal to Q0 is equal to 0. If an entry of a 4-bit binary number 111 is made into the register, this number should be applied in D base IN bit with the LSB bit applied first. The D input of FF3 D base 3 is connected to serial data input DI. Let's see here. दिस इज द ब्लॉक डायग्राम। ये देखिए, अब बहुत अच्छे से आप समझ जाएंगे। ये ऑपरेशन ये देखिए, हम ये ट्रूथ टेबल दी गई है यहाँ पे। दिस इज द वेव फॉर्म, ये क्लॉक स्टोर्ड वर्ड। ये देखिए, नेक्स्ट आता है सीरियल इनपुट एंड पैरेलल आउटपुट। In such type of operations, the data is entered serially and taken out in parallel fashion. Data is loaded bit by bit. The outputs are disabled as long as the data is loading. As soon as the data loading gets completed, all the flip-flops contain their required data. The outputs are enabled so that all the loaded data is made available over all the output lines at the same time. 4 clock cycles are required to load a 4-bit word. Hence, the speed of operation of SIPO mode is same as that of SISO mode. ये ब्लॉक डायग्राम है, देखिए अब यहाँ पे पैरेलल आउटपुट दिखा रहा। पैरेलल इनपुट, सीरियल आउटपुट। Data bit are entered in parallel fashion. The circuit shown below is a 4-bit parallel input serial output registers. जो सर्किट है वो मैं भी आपको दिखाऊंगा। Output of previous flip-flop is connected to the input of the next one via a combinational circuit. The binary input word B0 base B1, B2, B3 is applied through the same combinational circuit. There are two modes in which the circuit can work, namely shift mode or load mode. Load mode. When the shift load bar line is low, 0 and gate 2, 4 and 6 become active. They will pass B1, B2, B3 bits to the corresponding flip-flops on the low going edge of clock. The binary input B0, B1, B2, B3 will get loaded into the corresponding flip-flops. Thus parallel loading takes place. Shift mode. When the shift bar line is low, 1 and the AND gate 2, 4 and 6 become inactive, hence the parallel loading of the data become impossible. But the AND gate 1, 3 and 5 become active, therefore the shifting of data from left to right bit by bit on application of clock pulses, thus the parallel in serial out operation takes place. This is the block diagram. This is the parallel inputs and this is the output. Next is parallel input, parallel output, PIPO. In this mode, the 4-bit binary input base B0, B1, 2, 3 is applied to the data input D0, D1, D2, D3 respectively for the 4 flip-flop. As soon as the negative clock edge is applied, the input binary bits will be loaded into the flip-flop simultaneously. The loaded bits will appear simultaneously to the outside output side. Only clock pulse is essential to load all the bits. This is parallel output. नेक्स्ट आता है बाई शिफ्ट रजिस्टर. If a binary number is shifted left by one position, then it is equivalent to multiplying the original number by 2. Similarly, if a binary number is shifted right by one position, then it is equivalent to dividing the original number by 2. Hence, if we want to use the shift register to multiply and divide the given binary number, then we should be able to move the data in either left or right direction. Such a register is called bidirectional register. A 4-bit bidirectional shift register is shown in figure. There are two serial input, namely the serial shift right shift data input DR and the serial left shift data input DL along with a mode select input M. This is the condition and this is the operation. Universal shift register. Next is a shift register which can shift the data in only one direction is called a unidirectional shift register. A shift register which can shift the data in both directions is called a bidirectional shift register. Applying the same logic, a shift register which can shift the data in both directions as well as load it parallelly is known as universal shift register. The shift register is capable of performing the following operations: parallel loading, shift, left shifting, right shifting. The mode control input is connected to logic 1 for parallel loading operation, whereas it is connected to 0 for serial shifting, with mode control pin connected to ground. The universal shift register acts as a bidirectional register. For serial left operation, the input is applied to serial input, which goes to AND gate 1 shown in figure. Whereas for the shift right operation, the serial input is applied to D input. This is the block diagram. नेक्स्ट आता है हमारा काउंटर्स. Counter is a sequential circuit, a digital circuit which is used for a counting pulse is known as counting. Counter is the widest application of flip-flop. It is a group of flip-flop with a clock signal applied. Counters are of two types, asynchronous or ripple counters or synchronous counters. Asynchronous counter या फिर ripple counters. The logic diagram of a 2-bit ripple up counter is shown below. The toggle T flip-flop are being used, but we can use the JK flip-flop along with J and K connected permanently to logic first. External clock is applied to the clock input of flip-flop A, and Q base A output is applied to the clock input of the next flip-flop. देखिए, this is the clock, first flip-flop, second flip-flop. This is the logic, toggle T, Q, and this is the output. The operation conditions and operations you can study one by one. Truth table. Next is synchronous counters. If the clock pulses are applied to all the flip-flops in a counter simultaneously, then such a counter is called a asynchronous counter. 2-bit synchronous up counter, the JA and KA inputs of FFA are tied to logic first. So FFA will work as a toggle flip-flop. The JB and KB inputs are connected to QA. This is the logic diagram. These are the conditions and operations. Now the classifications of counter. Depending on the way in which the counting progresses, the synchronous or asynchronous counters are classified as follows: up counters, down counters, or up down counters. Next is up down counter. Up counter and down counter is combined together to obtain an up down counter. A mode control M input is also provided to select either up or down mode. A combinational circuit is required to be designed and used between each pair of flip-flop in order to achieve the up-down operation. Type of up-down operations: up-down ripple counters, up-down synchronous counter. Up-down ripple counter. In the up-down ripple counter, all the FF operation in the toggle mode, so either T flip-flop or JK flip-flop are to be used. The LSB flip-flop receive clock directly, but the clock to every other FF is obtained from Q is equal to Q bar, output of the previous FF. These are the up counting mode, M is equal to 0, down counting mode, M is equal to 1. This is the example, and this is the block diagram, truth table. This is the operations and conditions applied for up down counters. Next is modulus counter, mode and counter. The 2-bit ripple counter is called as MOD, modulus counter, and 3-bit ripple counter is called as MOD 8 counter. So in general, an n-bit ripple counter is called as modulo n counter, where MOD number is equal to 2 की power, and type of mode modulus 2-bit up or down, MOD 4, MOD 8. Applications of counter: frequency counters, digital clock, time measurement, A to D converter, frequency divide circuits, digital triangular wave generator. तो ये थी आज की हमारी क्लास. आई होप यू लाइक इट. Some of topics in this class are important, so you study. Thank you very much.